For Lesson 20, we're going to practice writing and evaluating expressions using multiplication and division. So we start with exercise 1 that shows the farmer's market is selling bags of apples, and in every bag there are 3 apples. So we complete the table. For 1 bag there are 3 apples, for 2 bags there would be 6, for 3 there would be 9, for 4 there would be 12, and for B there would be 3 times B. If the market had 25 bags of apples to sell, how many apples is that in all? Well, that would be 3 times 25, which is 75 apples in all. If a truck arrived that had some number A, more apples on it, then how many bags would the clerks use to bag up the apples? In other words, if we know the number of apples, how many numbers of bags would it be? Well, we would need to take A, the number of apples, and divide it by 3, because there are 3 bags, or 3 apples in every bag. If a truck arrived that had 600 more apples on it, how many bags would the clerks use to bag up the apples? So then we substitute 600 divided by 3, and we find that they would need 200 bags in order to bag up all of these 600 apples. How is part D different from part B? Well, in part B, we have the number of bags of apples, and we are trying to calculate how many apples in all that is. So the smaller number, the number of bags, times 3 to get the larger. Where in D, we have the number of apples, the larger number, and we're dividing it to find the number of bags. So they are opposites. Example 2. In New York State, there's a 5-cent deposit on all carbonated beverage cans and bottles. When you return the empty can or bottle, you get the 5 cents back. So we're going to complete the table. If one container is returned, the refund in dollars would be 5/100ths of a dollar. It's a 5-cent deposit. Remember, this is in dollars. If it were 2, we would get 10 cents. 3 would give us 15. 4 would give us 20 cents. Watch your table. 10 is going to give us 50 cents. 50 will give us $2.50. 100 will give us $5. And C would be 5 cents times C. Remember, always in dollars. If we let C represent the number of cans, what is the expression that shows how much money is returned? Well, this is our expression right here. Five 100ths times C. Then we can use the expression to find out how much money Brett would receive if he returned 222 cans. Which is $11.10. Then if Gavin needs to earn $4.50 for returning cans, how many cans does he need to collect and return? Now in this case, we're going to need to work backwards. So we're taking $4.50 and dividing it by 5 cents a can. And that tells us that he needs to collect and return 90 cans. And E, how is part D different from part C? Well, they are opposite operations. Because they're showing forward and backward the same relationship. Example 3. The fare for a subway or a local bus ride is $2.50. We're going to complete the table. If there's one ride, $2.50. For 2 rides, $5. 3 rides would be $7.50. 4 rides is $10. 5 rides is $12.50. 10 is $25. 30 is $75. And R would be 250 times R, or we could also write it as 2 5/10 times R, since the zero, trailing zero in our decimal isn't necessary. If we let R represent the number of rides, what is the expression that shows the cost of the rides? It is 250 times R, or 2 5/10 times R. Now we'll use that expression to find out how much money 60 rides would cost. So we'll substitute 60 for R and then multiply. And that will give us $150. And then in D, if a commuter spends $175 on subway or bus rides, how many trips did the commuter take? So we'll take our 175 and divide it by 250 for each ride. And that will be 70 trips. Again, how is part D different from part C? They are opposite operations. Because they are showing the same relationship forward and backward. Example 4. A pendulum swings through a certain number of cycles in a given time. A pendulum is like an old-fashioned grandfather clock. It has a long part to it, and then it swings back and forth. Owen made a pendulum that swings 12 times every 15 seconds. We're going to construct a table showing the number of cycles through which a pendulum swings, and we'll include data for up to 1 minute. We're going to use the last row for C cycles and write an expression for the time it takes for the pendulum to make C cycles. Before we do anything else, we want to do the number of cycles in the first part of our table, and then the time in seconds in the second part. Okay, we know that it swings 12 times every 15 seconds. 12 cycles, 15 seconds. And we're asked to include data for up to 1 minute. So let's complete our time in seconds first. Every 15 seconds, so another 15 seconds would pass. That would be 30 seconds. and another 15 seconds would be 45, and another 15 seconds would be 60 seconds, which is 1 minute. Now let's go over to the number of cycles. Again, it's 12 cycles for every 15 seconds. So as these double or increase each time, these will also increase. 12 plus 12 more is 24, plus 12 more is 36, plus 12 more is 48 cycles. And again, our expression then, the last row for C cycles, the time it takes for the pendulum to make C cycles. And if we do 15 it's 15 seconds for every 12 cycles. Listen to the phrasing. 12 times every 15 seconds. So if we have 15 times C divided by 12, times the number of cycles divided by 12, that will give us the amount of time. Owen and his pendulum team set their pendulum in motion and counted 16 cycles. What was the elapsed time? So 16 cycles, we would take our expression, 15C divided by 12, and we're going to substitute 15 times 16 divided by 12. And that will be 20 seconds. So in part C, they ask us to write an expression for the number of cycles a pendulum swings in S seconds. So if we take the relationship of cycles to seconds, that would be 12 to 15. Please notice 12 to 15. And then we multiply that times S. What we have is 12/15 S. And we could simplify our fraction, because both 12 and 15 are divisible by 3. And that would give us 4/5 times S, or 4/5 S. Or even as a decimal, 8/10 S. So in a different experiment, Owen and his pendulum team counted the cycles for the pendulum for 35 seconds. How many cycles did they count? Again, S represents the seconds. So what we can do is take our expression that we just determined and multiply it. Well, let's start with the original expression. And then substitute 35 and then we find 28 cycles. So if we look for the relationship in the table, or when we have a table, we make a relationship from the table. Then we can use that relationship to find any missing information, even if it doesn't appear to fit into that table.